Hello, good morning. Today I'll share some insights, some notes on the difference between distance time graph and speed time graph. Because I noticed that some of my students, they get confused when to use which formula for which graph. Okay, so let's proceed. Okay, let's see the difference between the distance time graph and also the speed time graph. So for distance time graph, y-axis is distance. Normally it's kilometer, the unit kilometer or meter, And for the time, when kilometer, the partner is hour, and if meter, it will use seconds, seconds. Okay, let's start with and for speed time graph, the unit will be kilometer per hour, the unit for speed, or meter per second. So the time will be in hour or in second, depends on which one lah. If meter per second, so the time will be second. And this one also can be written like this, power -1. This one is the same thing. It's the same thing. Okay, let's see the first graph. That is the OA. So for distance time graph, what does this meaning? This graph. As you see, this graph is going up. So there is a change in distance. There is a change in distance over time. So this is what you say, there is a rate of change. There is a rate of change in what? In distance over time. So it is actually the speed. You can calculate the speed here for OA. For OA, you can calculate the speed. The speed. So how do you calculate the speed? Yes, you just use gradient. You just use gradient to calculate the speed. Meaning to say, speed is equal to gradient. So how do you do that? How do you do that? Okay, so you just find the change in your distance, your y-axis, and actually it is the distance, and then you find the difference in your x-axis, that is your time. So your gradient will be d over t. This is actually your speed. You can use this, it's like your formula. For distance time graph, you can use this one, dsT. So S meaning distance over time. So you can see here, this is distance over time. And that's why you get your speed. The unit is, because this distance is kilometer, time is hour. So you get your unit kilometer per hour. Okay, so now for speed time graph, what does this mean? This one. The speed is increasing, with time. So you can say it is the rate of change in speed, over time. And you call this acceleration. Acceleration. Why acceleration? Because your speed is increasing. If you start driving, you start with 0, right? Kilometer per hour, let's say lah. When you press your gas pedal, it's also known as your accelerator pedal. You press and it's going up, 10, 20, 30 kilometer per hour, it's going up. So there is a rate of change in speed. This is what we call acceleration. You're accelerating your speed. But for this one, the speed does not change. The speed is uniform, yeah? It's uniform speed. Why? You can see here the gradient. Yeah? Gradient is always the same. The big triangle, the small triangle, is all the same. So the speed is uniform. But here the speed is increasing. It's called acceleration. And the unit is kilometer per hour square. And how to find it? You use gradient. The same thing with how to find the distance time graph. You find the change in speed or in y-axis. You divide the change of the difference in time. Yeah. So acceleration is the change in speed over the change in time. Yeah. So speed, the unit is kilometer per hour over hour. That's why you get your this one. The unit is kilometer per hour square. That's why you have square here. Yeah. Okay. So next. AB. What does AB mean? What does AB mean? Okay, for distance time graph, AB means here. It doesn't have any change in speed. Yeah, the speed is constant. The distance does not change. So if no distance, that means it's what? It's stationary or it's stop. Yeah, it's stop. Okay, but for speed time graph, what does this mean? AB means, here the speed is constant, no change in speed, so it is uniform speed. Yeah, here is uniform speed. Yeah, here stop. Okay, next for BC. If you see here, BC, the distance is going down. Yeah, it's decreasing. When distance decrease, that means it go back to origin or to the start. This one is go back. This is moving lah, moving to destination. Okay, and for this one, the graph for speed time graph, the meaning is what? The speed is decreasing. Yeah, so when you press your gas pedal when you are driving, actually you're not pressing it, you let it go. Let it go. So the speed is decreasing. So you call that the rate of change in speed over time, but the term is decelerates. Yeah, deceleration. Speed going down. Yeah, decrease. And the unit is still the same, but gradient, to find the acceleration, you find the gradient, you'll get a negative value. Yeah. Okay. So this one go back. This one is actually deceleration. Okay. Last one is about average speed. Average speed, normally students will get confused when for this graph. distance time graph and also for speed time graph, what they do, they find the speed, yeah, they find the speed, and then they find the average, yeah, they divide by 2, and this is the wrong way to find the average speed, yeah. There is a formula that is the total distance over total time. So for distance time graph, how do you find the total distance? How do you find the total distance? Total distance is, this one is moving, yeah, it's moving, going to destination. Let's say Alda wants to go to school. So this graph is when Alda go to school. Let's say it's 2 kilometers. Yeah. So here Alda stop. Alda is doing the lesson lah. Yeah. And then for a few hours, then this one is what? Alda going back. How many kilometers? Still the same, 2 kilometers. So total distance for Alda is what? Total distance. Of course, you have to plus lah. 2 plus 2. So let's say the first one is what? A plus B. Yeah. A plus B here. A is the one go to school, B is going back to school from school. So divide by time, here the time. Yeah. So that is for distance time graph, how to find the average speed. But okay, for speed time graph, how do you find the total distance? Yeah. You want to find average speed, so you need to find the total distance. Total distance is here. Where can you find the distance? From the graph you cannot find, yeah. This is speed, this is time, yeah. But for distance time graph you can find, because this is distance, yeah. The graph is distance, so the distance is from the graph. But here you cannot. So you learn about what? Area under the graph. Yes, area under the graph. So what do you see here? This is a trapezium. So you just find the area of the trapezium. Yeah, area of trapezium 1/2 times the what? The height. Yeah, the height, and then you times with the here the parallel line, yeah. Yeah, A plus B lah. Let's say A plus B. So you just use this, you get the distance, total distance, yeah, and then over time. Okay. Okay, now let us describe, yeah, the distance time graph and also the speed time graph. How the object moves, yeah. So you start with OA. OA, the object is moving with the uniform speed, and then it stops for a while. How long? T2 minus T1, yeah. You find the time, this is the duration. And then after that, it go back to the start, yeah. Okay, so in words, in sentence, you say the object moves at uniform speed, yeah, that is OA, then stop for how long? T2 minus T1, and moves back to origin, yeah. But now for speed time graph, it's totally different, yeah, it's totally different. First, the object is for OA. Yeah? For OA, the object is moving with an increased speed. You say it acceleration. Yeah, acceleration. And then for this one, it is moving, still moving. at uniform speed. Uniform speed. And then after that, for how long? Uniform speed, this one lah. T2 minus T1. You have to find the time. And then it decrease in speed, that we call deceleration. And finally it stop. Finally it stop. Okay. So in sentence we say the object moves, increase speed, that is accelerate. Then move at uniform speed. For how long? Then decrease speed, you say decelerates, and then stop. Okay. Now, do you see the difference? Do you see the difference? Uniform speed for distance time graph is OA, but for speed time graph, it's here, AB. It stopped at AB, but it stopped here. Yeah, stop here. And then you can find the distance. Yeah, for distance time graph, you can find the distance from the graph. You can just have a look and then you know what's the distance, right? But for speed time graph, okay, we go back here. The distance, you just find what's the distance here. Yeah, here, and then you plus the distance here. It will be the same. If this one is 10 km, this one also 10 km. But for speed time graph, yeah, distance, you can find the distance, but you have to find area under the graph. Depends which area you are asked to find. If it is at T1, so you just find the triangle, the area of the triangle. You get the total distance. You get the distance. Yeah, depends. Depends. If the whole journey, that means it's a trapezium lah. So you know, you have to know at least 3 formula lah. Formula for triangle, formula for rectangle, and formula for trapezium. Yeah, all this you have already in your fingertips. So that's it, class. That's all for the difference. Some notes for you to understand better for graph of motion, especially for distance time graph and speed time graph. So with that, thank you very much.